Word.
Meeting is being recorded.
Okay, so we should be recording. All right. So I think we're going. The premise of this is if we have a good process that builds validated requirements, then I don't have to inspect quality in at the end. So we have evolved from, I have no idea what a good requirement is, to we have some idea what a good requirement is, and when it's all done, I'll look at it and tell you, to ultimately what we want is a process that delivers validated requirements. And we'll talk about what we mean by validated. Hopefully. Now, why is this not working? All right. Well, so just go. All right, some new materials. Lauren already mentioned the new system engineering handbook. The numbering is different. It does match the ISO standard from which it's derived, but the numbering is different. There's also a brand new guide to writing requirements, version 4. It came out in July. And there's also a new guide to needs and requirements that was published last year, and a 400-page needs and requirements manual. That's everything the requirements working group thought anybody needed to know about that. There's also the new ISO standard, which is consistent with the SE handbook. Systems and software engineering published this year. And there's also a requirements engineering ISO standard, but it's no longer consistent because it was published in 2018. So the section references won't match. But a lot of the INCOSE guide material comes out of that and elaborates it. I mentioned, for those of you who work at Boeing, John Palmer, senior tech fellow now, was the original author on this, and I updated it before I left, a requirements definition standard. And I still believe this is even superior to the INCOSE guide to writing requirements. So those of you who are fortunate enough to work at Boeing should take advantage of that. It's a BDS document. So in the last year, I had learned there's another organization that is doing requirements engineering. In fact, there's a certification by the International Requirements Engineering Board. It's based in Germany. They seem to be focused on software. There are 70,000 people certified. Wow, didn't even know about that until a year ago. So you can go get certified in requirements engineering through this organization. They do have some training available. Most of it is in German. So, but there's online stuff available, and they have online materials. So if you want to get certified in requirements engineering through this, that's available.
German or English?
The material's in English. Well, it's in both, but I mean, you can get it in English. Yeah, you can choose. It's a lot of good online stuff. I have a lot of references. Most of this is in the INCOSE Wiley library, publication library, and everything that's hyperlinked to YouTube, it's on the YouTube channel. So if you don't want to read it, you can just listen to it and watch it. This is all my INCOSE papers, a couple of patents, and a couple of other videos, and I'll hopefully add this video to the mix. So what I'm going to talk about today, requirements, validation, templates, how do we derive requirements, how do we ensure they're complete. I'll touch on one of my YouTube videos using architecture and MBSE, talk about measuring requirements quality. If you come to the tutorial, we'll do some actual work, some real examples, and you get some practice writing and evaluating your requirements. What is a requirement? You'd think it's simple, but it's not. It's a mandatory provision. The best definition, one of the early ones, from Rick Harwell, 1993. If it mandates that something must be accomplished, transformed, produced, or provided, is a requirement, period. That sort of got lost around 2000 when people started treating requirements as something other than mandatory. This definition is consistent with what you find in the dictionary. It's important that we consider mandatory provisions. It's not a design description, it's not a goal, it's not a desire, it's a basis for acceptance of the solution. And if you don't treat it like that, most of what I say tonight goes out the window. So Tradable requirement is an oxymoron. If it's a basis for acceptance, it's not tradable, period. Software community sort of messed this up, and I had arguments with people in the requirements working group. Oh, well, you know, requirements aren't just mandatory. Well, that's a problem. So I went into that a little bit in the 2004 paper. So it's something that's mandatory, means it's basis for acceptance of the solution. There should be some means of designating in the requirements what's a requirement, what's not. We generally use the keyword shall. People were talking about must. Interestingly, the INCOSE guide says don't use must, but you can use whatever word you want as long as you define it and say any phrase that any statement that has this keyword is a mandatory provision. So we get ourselves in trouble if we don't insist on the concept of mandatory. So people talk about tradable requirements. It's an oxymoron. Don't go there. New INCOSE guide requirements spends a lot of time talking about needs and formalizing needs. And they say the focus of the needs should be on an entity, something that's going to do it. And there's some allocation to some entity, and the definition I'll talk about some more on Saturday about that has to be agreed to with a stakeholder. And I'm thinking, well, people state needs, and we just got to accept that. But this is what I derived from. Oh, I can't use the laser pointer because it reflects off the screen. Yeah, that every time I try to use it, it's like it bounces there. You don't see it on the screen. So, well, it's an interface mismatch between a laser pointer, which is an earlier generation, worked fine for overhead projectors, right? Don't work on reflective screens. Anyway, the design input requirements, which is a term that doesn't exist in the System Engineering Handbook, but is talked about in the guide. There's a lot of work that goes on in this integrated needs section, but it talks about it being entity specific. In other words, they've already figured out what's going to do it. I don't think that's the right answer, but this is the process that gets outlined. The guide recommends formalizing needs as well as requirements. I put in a comment that said, I think that's a waste of time. But my comment was rejected. So there we go. So they have a whole section on needs, and you can formalize requirements if you want. I think it adds an extra process step, and it makes it difficult to differentiate needs and requirements. So the focus, in my mind, the focus of needs should be on satisfying stakeholder mission and objectives. However they state it. Stakeholders aren't requirements engineers. They don't know how to state what they want. They just want to state what they want. So we got to accept that. They also don't always care about what the solution is. I have a need, want it to be satisfied. You come up with an answer. And if they have any sort of system engineering inkling, they would recognize that they may not be able to predict what the ultimate solution looks like. And they would be happy as long as you satisfied their problem. So my recommendation, and I think it's actually more consistent with what's in the System Engineering Handbook, is we collect up the needs, and then we refine, deconflict, prioritize, allocate, and validate them into stakeholder requirements, which is the second technical process. And from that, we derive what's going to be the system requirements. I think that's a better way to go. We elicit and collect needs as they're stated by the stakeholders. And I'll show you a quick example. And then we analyze, prioritize, refine collected needs and do verifiable requirements. So this business in the System Engineering Handbook, this is what I teach in the certification course. I'll be going to China next week. I think my managing director is online, and she's managing director for Certification Training International, Renee King. And if you want to get trained, you can contact me or her, and we'd be happy to set you up with courses either for your company, or we have public offerings scheduled throughout the year. So that's my shameless plug right now. So here's an example. Client, perceived needs. I need a new car. Now, most engineers, the first thing they would say is, oh, what kind of car do you want? Right? That's not systems engineering, right? right? All you system engineers say, that's not systems engineering. You need a new car. Well, what do you want to use it for? Right? I want to show clients available real estate. Oh, okay. Now I've got some idea what the mission is. This might be a realtor. How many clients do you need to hold? What other characteristics are most important to you? You know, we start asking questions to derive what are going to become the requirements. I never ask clients what the requirements are. They don't know how to state them. They just know what they think they want. I need a new car. Up to 4, it needs to communicate success. So in the value engineering world, that's an aesthetic requirement. So we might come up with something like this. You know, how's that look? You know, or the person might say, I need a new car to get to work. You say, well, how far you have to go, how fast, you know, how quickly, how often do you have to go? We may find out they need a car, they need a transportation system, depending on where they are. So we don't reject the statement. What we do is find out what's behind it by asking questions. That is the critical art of systems engineering that is forgotten about. We don't immediately jump to the solutions. So why do we have requirements? It's a technical contract. Most of you work in companies where you're signing technical contracts, either as an acquirer or a supplier. So they define the expectations and acceptance criteria, and it's a verifiable means. In other words, you can prove whether it's satisfied or not. Lots of organizations love to have ambiguous requirements, and then you get to argue about it for a long time. And I'll talk about that a little bit more on Saturday. I think we're going to be stuck with text requirements for a long time because of contracting, and I don't think we'll be going to model-based contracting, mainly because acquirers probably can't live with the risk that somebody would actually deliver what they defined in the model, right? It's hard to be perfect in a model. So, yeah, we delivered, it works exactly the way you presented it to us in the model. Yeah, but that doesn't do what I want it to do. It doesn't solve my problem, not my issue. We built your model, okay? So I don't think that's going to happen. Ultimately, the requirements may not actually satisfy the need, and that's why we have to be careful when we're defining requirements to make sure, and this is part of validation. If we don't have requirements, you know, see Agile, then there's no basis for evaluation and assessment other than user and stakeholder feedback. And that is the essence of Agile. Here, I built something. How do you like it? Oh, fix this. Okay, I built something else. How do you like it? Fix this. And we don't really need requirements. The paper I did 2013 talked about that. What you really end up with sometimes is, well, they have test cases. Well, the test cases turn into the requirements. So anyway, you can look at that paper if you want. It's on the, no, it's not on the YouTube channel, sorry. All right, what do we mean by validated? I gotta watch my time here so it doesn't get away from me. So the handbook, new handbook, validation process provides objective evidence to confirm the right artifact or entity has been made according to stakeholder needs and stakeholder requirements. And requirements are just one of those things that's getting made, right? So it's both having correct requirements and no unnecessary requirements, including the defined behaviors and other characteristics that they are correct and complete. So that's language out of commercial airplanes, ARP 4754A. Who would be calling me right now? Oh, it's my mother, sorry. Sorry, Mom, I'm in a meeting. Gosh, that's on the YouTube. That's going to be on the recording. Okay, so don't tell her. So we want to make sure there's nothing missing and there's nothing extra and that everything in there is correct, because these are going to become the acceptance criteria for the system. There's a chair here. There's a chair here. Josh, there's a chair over here in the corner too. Josh? Yeah. You want to squeeze in, sorry. Yeah, can you see? I'll try and step back. Stakeholder measures of effectiveness are also something that we have to be sure we pay attention to, sir.
So, about the naming of validated requirements, doesn't it confuse people with validation? Like validation is very fast.
Yeah.
A validated requirement is a different concept. Don't they interfere with each other?
Yeah, can you hold that? I'll come back to those questions later, but yeah, we're often, and you notice it's 511, so that means it's the 11th of the 14 technical processes, and usually we think about that happens later, but validation is really something that happens continuously. Anything you produce, you should be validating. I have a set of stakeholder requirements. Are they validated? Or did you just make them up? You know, did you go through and, you know, they're actually derived from some stakeholder need measure of effectiveness. So you can say, this is why we have this, and this is why I know its statement is correct. Yes, we often treat validation as something that happens when we put a system into operational use, and that's part of its definition, but validation actually is a technical process that should be applied to everything we produce. So stakeholder measures of effectiveness, their missions, their goals, etc. Oh, yeah, so we have the mandatory criteria, then other things like goals and desires can be handled as a value proposition. Hey, we can give you more of this above your threshold, but it's going to cost you a little bit more. So there's a value proposition. Are you willing to pay more for this additional capability above your threshold? They say yes or no. Well, how much is it going to cost? But we want to make sure we have no unnecessary requirements. In other words, no requirements that are not mandatory acceptance criteria. That adds cost. It adds cost just from the fact that we call it a requirement. We have to manage it. We have to keep it under configuration control. We have to get it approved. We have to argue about it. We have to write verification cases. We have to prove at first article inspection or whatever that it's actually satisfied. And here's the data. Oh, well, that really wasn't a requirement. Well, then why did you include it? So one of the important jobs in systems engineering, requirements engineering, is to get rid of all these unnecessary requirements. Mike and I were on a workshop 13 years ago. We went through a whole bunch of specs on a program, recommended they could get rid of 40% of the requirements, 40% of the requirements in their supplier specs. Why? Because they were duplicates. 40%. That's a staggering number. That's expense. That's zero value, negative value expense. So we don't want to have unnecessary requirements. Requirements verification is 2359. So verification is a 9, validation is an 11. It's talked about in the handbook, but it doesn't describe how it's supposed to be applied to requirements. So this is material from a paper I did with Bob Noel, also at the Boeing Company a few years ago. Some of this has actually now been captured in the Guide to Writing Requirements in section 214.
I'm dropping in on the Seattle
letters, but that's okay. So it's verified and validated set of requirements. That is, it's correct and complete. It's composed of validated and verified requirements. Validated satisfy the stakeholder needs.
I think it's supposed to rain tomorrow.
Requirements. Verified, they satisfy a parent requirement and conform to a template. And those are pretty much the definitions that are in the handbook.
It was cloudy,
but it didn't. From that, we derive that we're going to get a correct set of correct requirements. We derive top-level requirements based on operational and top-level needs from the stakeholders and their measures of effectiveness. And then we derive lower-level requirements for the system and below that are verified compared with the parent requirements and needs and any standards like requirements definition standard. At each architectural level, so we can have levels of requirements. These yield correct set of correct requirements if we've done these things. And that's what we mean by verified and validated or correct and complete depending on which language you like to use. ARP 4754A uses correct and complete as described in those sections, and I have a couple of tables explaining those. So I say these are the same things, but we decided to use correct set of correct requirements, and the latest guide to writing requirements actually uses correct set of requirements now as well.
You want questions later?
Yes, please, because otherwise I'm worried I won't get through what I want to. So we have a correct set of correct requirements. That means each requirement is correct and there are no unnecessary requirements. That means correct. There's two types of correct. First, there's a type 2, no missing information. And for that, we have a verifiability criterion. And that's where we started on our quality of requirements at Boeing a long time ago. The statement is sufficiently clear and complete to be able to prove that it is needed, sufficient, and feasible. You can prove it by the way it's worded. This doesn't tell you that it's got the correct content. It just says it's provable. There's no missing information. And it's sufficient if we satisfy this requirement, then the parent requirement or need will be satisfied, and we can prove that. Now, not everything can be, put in a closed form solution and decomposed, and sometimes you have to do analysis and simulation. But the point is, you can deterministically state that we can satisfy the parent need based on this requirement and this analysis. The other type of error or correctness is there's no erroneous information. We have the right performance attributes, we have the right condition statements, we have the correct allocation. So the first thing is it's a necessary requirement. We cannot satisfy a parent requirement or need if we don't have this. In fact, that's my test for necessity is, well, what if we delete that requirement? Well, nothing will happen. That's how we propose the 40% on that program. Oh, well, that's covered by another requirement. Then I guess that one's not necessary, right? Oh, yeah, I guess so. Okay, so we want to get rid of unnecessary requirements, and we want to make sure that all the requirements are feasible, and the new guide uses achievable for that as well. So requirement can be satisfied within the program constraints with acceptable risk. Right? Everything's a risk. Can we live with the risk? Technology maturity, budget and schedule. What you can't do is violate the laws of physics. That will never be feasible. Sorry, that's just not going to happen. So I'll have more time to chat about things on Saturday if you want to hear more stories. So you have to come Saturday if you want more stories. We say that these are disjoint, concise, and complete. In other words, they're necessary and sufficient to determine we have a validated set of requirements, that it is correct and complete. So this is how we get our correct set of correct requirements with these 4 characteristics. We basically are decomposing this concept of a validated set of requirements, which enables us to do measurement to see how well we're doing. Did we actually achieve those? So I got 2 pages of the characteristics of requirements. They're not actually stated as the validation criteria, but they're kind of used that way. So there is a set that apply to individual requirement statements, and they've got a few things in unambiguous, appropriate, necessary, and I've put our mapping to our 4 characteristics over in the right-hand column. So this is updated from our 2018 paper. They do have a section called verifiable and validated, which states that requirement statement structure worded such that its realization can be verified to the approving authority's satisfaction. Notice also these definitions also apply to need statements, which, again, you can do that if you want. I think it's extra work. I think it's not lean. So there's 9 characteristics applied to individual requirements, and then there are an additional 6 more that are applied to sets of requirements. And we've also mapped these to our 4 criteria. Completeness, consistency, so this is where you would find conflicts. They go into more detail on consistency, like terminology and units that we don't get into. Feasibility of the set, we also agree that's important. And a couple of other things able to be validated. The new one is correct set, which I think they probably got from our paper, which is fine. But it's sort of an umbrella, doesn't really have an individual measurement. The set of requirements must be an accurate representation of the needs, sources, or higher level requirements from which it was transformed. What was missing, and is buried in some of the language, is the idea of sufficiency. It does appear in their completeness characteristic. We think that's a critical characteristic, and it was worthy of having its own call out. In other words, if I do this, is it sufficient to satisfy the parent? So that's the way we looked at that. All right, so why do we have 4 characteristics? Well, because there's a lot of overlap among the INCOSE guide requirements, and they admit that. In section 2.1, they say, yeah, we recognize they're not disjoint, but we're going to leave it anyway. I think that's because of now the history, because that thing's been out there for 10 years. And the ISO standard has some of the same characteristics. And I think they just thought it might be too hard to lean it out and fix it. But I'm not constrained by that, so I do what I think is right. So we have the 4 characteristics. Verifiable ensures no ambiguity, and it covers a whole bunch of things. Completeness, if I go back to my original papers starting in 95, necessary and sufficient. So the necessity criterion actually has a one-to-one mapping. The sufficiency is actually covered by a number of things here. Sorry, Josh, I'm keep blocking your view. Feasibility is about ensuring that we have manageable risks and the ability to detect conflicts. Because if I have conflicting requirements, then at least one of them is not feasible, right? So that covers a number of things, both individual requirements and the set of requirements. And there's a whole bunch of papers that I traced to, but you can see some of their characteristics appear in at least 2 of our criteria, just because of the wording that's in their definitions. So that's the way it is. So when we put this all together, we have a Venn diagram for a requirement set that a requirement cannot be correct unless it is necessary, sufficient, well, verifiable is the big umbrella, right? You can't tell any of the others easily unless you have verifiability. Then it also has to be necessary, sufficient, and feasible at the individual level and over the whole set. Sometimes you can have good requirements, but you can't accomplish them all in the program. Not enough time, not enough budget, so the set becomes infeasible. Consistency, excessive risks. So we put the little set theory model here. It can't be correct and complete unless it satisfies all these criteria. And if we have correct sets of correct requirements, then we have verified and validated requirements, is my assertion. So here's a checklist. Is it mandatory? Better be. Is it written such that it could be objectively confirmed or falsified? Better be. Necessary. Could we satisfy all user needs even if we deleted it? You can take this checklist home, by the way, and use it. Sufficient. If we satisfy this requirement, will we satisfy the measurable stakeholder needs? And are all stakeholder needs being addressed by the set of requirements? Traceability can help you with that, but you also need some analysis to know that your statement of the requirement actually satisfies the requirement. And those of you who are attending the tutorial, I'm going to send this whole thing out. So if you sign up for the tutorial, you get the presentation package. Feasible. Can this requirement, in combination with all others, that's a critical phrase, be implemented with acceptable risk given the budget, schedule, and technology? So that's the checklist for validation. Getting to validated requirements. So now we know what the target is. Now, how are we going to get there? Well, first thing is, what's the structure of the requirement we're going to need to be able to have validated requirements. So target format, this determines what the data are that we need to be able to produce our validated requirements. That means we have to define a requirements standard, which is where we started at the Boeing company 10 years ago, John Palmer over there, thank you. There's now some material in the Guide to Writing Requirements, Appendix C. I talked about this in 2001, 2015. Physio-Control actually published a paper in the 2001 proceedings that had a structured requirement in it that I reference later. The idea is the target enables defining the process. If I don't know what I'm trying to accomplish in terms of the work product called a requirement, it's impossible to figure out what the process is that's going to give that to me consistently. So I have to know what I'm trying to get to. So we start with the requirement standard, the who, shall, what, how well, under what conditions. I learned this 30 years ago, system engineering manager. Okay, that works. You know. Why is this correct content? It's necessary and sufficient for verifiability. I can prove or disprove that a system satisfies requirements that satisfy that template. It defines the responsible system or organization. The Guide to Writing Requirements uses the word entity for the who. Defines the mandatory characteristics or behavior, that's the what. How well defines the measurable attribute of the what. And under what conditions defines when. So got everything you need. By the way, you can use that for statement of work things as well. It's not just system requirements. Anytime you're creating an obligation for somebody, it's a verifiable construct. So a little bit more, who, the entity allocated the requirement, performs the action or has the characteristic. We want to avoid passive voice. Often you'll see requirements that are stated as the what shall be how well. Like the temperature shall be kept within a range. Oh, that's nice. Who's going to do that? You know, what's the allocation? So, so our construct is always the who shall what how well, not the what shall be. So watch out for shall be. It may be okay if it's like a design characteristic. The weight shall be, the system shall have, the system element shall have a weight between. So my use shall be for something like that, but be careful. Shall, some keyword. I'm fine with must. The Guide to Writing Requirements says don't use must, doesn't matter. But define it and use other words for other things like should for a goal or objective, will for intent, may for an option, and is for a description. You can define those up front, keywords. Shall not. Real problem. Never use shall not in a functional requirement. Impossible to prove. So find some other means of stating what you need, like shall inhibit. Make sure some other positive statement. The what? Function or some other characteristic. Key, observable function. If it's not observable, you can't verify it. So that means you also have to identify the external interface. Where's the output? So some of the early Guide to Writing Requirements training, the system shall raise an alarm. I was in a meeting, they were explaining this training, and I said, so does it mean there's a flag that goes up? Well, they weren't real clear about that. So I said, is it a flag, an audible warning, or a flashing light? And is any one of those okay? Well, it wasn't clear. I think they had a concept in mind, but if you don't identify the interface, it's not clear what you're after or what would be acceptable. So be careful of functions, make sure they're observable, make sure they're defined on some interface, and avoid non-observable functions. Okay, here's a set of bad words. Everybody likes bad word list. Receive, monitor, calculate, isolate, integrate, identify, store. They're all bad words. Why? You can't observe them, can you? How would you know? Upon, the system shall receive a message. How would you know it did? Well, because it's going to do something. So that receive is an input that initiates another behavior that you can observe. So why don't you combine those two requirements into one good one? Upon receipt of this, do something that's observable. Oh yeah, Okay, so bad word list. Store, yeah, questionable. You may be able to interrogate a store, maybe. Just make sure you can. All right, so ask, where would I observe this? So be careful of functions, make sure they're observable. This was a good addition to the guide to writing requirements. Finally got them to add the adjective observable ahead of function. So that's a good thing. How well? This is the performance attribute. Provides a measurable attribute of the function or characteristic. This is what we're going to use to determine whether this requirement's actually satisfied. Like it's got the sufficient range. There's a number. You pass or you fail. The car shall drive a long distance, right? So there's no measurable attribute there. You know, this is especially important like electric vehicles, right? Minimum range under all conditions. Woo, tough one, right? But that for somebody who has an operating concept, that becomes critical. I have to have at least, you know, a 70 mile per hour, 70 mile round trip range under all conditions, or I can't use it for its intended purpose. And if it's 69, it ain't gonna work because there's no charger 1 mile from my home. Okay. This also includes timing for initiated events, in addition to the measurable attributes of the functions. Must be clear about implicit tolerances. These get really difficult. So for those of you at Boeing, we went into this in a lot of detail in the requirements definition standard, but is it a minimum? Is it a nominal? And if you put uncertainty on it, is that a min-max or root mean squared, or what does it mean? So be careful of significant digits, careful about less than, greater than, at least. They all have slightly different meanings, and you'll get into big battles in verification over whether something passed or not. She's nodding her head back there, yes. See your scars, yes. Under what conditions? The guide in the appendix C3 goes into this in a lot of detail. They use different keywords. Gentleman, Maven 2009 has easy something for requirements. Anyway, different patterns for especially about condition clauses. I like upon for an initiated event. I like while for a continuous condition, like a state condition or environmental condition. Other people use other words. The guide allows you to put the condition clause first. We actually had made that an option, but we found that people thought it was too confusing, especially as the condition clauses get longer and longer. It's hard to find the shall. So we just said, we're just going to put the condition clause at the end, unless it's a triggered event. So, but this is a stimulus response construct. You could put the condition clause first, and that's okay if everybody thinks it's okay. We don't like when because it's ambiguous as to whether it's a continuous action or a triggering event. So I just decided I'm not going to use that. So upon and while were the two keywords we used. And complementary set, and we're going to talk about completeness in a little bit. To make sure we have covered all possible conditions. Well, what do you want to do if that message doesn't come in? What do you want to do if we're not in that state? So we want to have some requirements worded as upon not or failing to receive a particular input at a particular time, or while not in a certain state. In other words, I'm supposed to do this in this state, but I'm not doing this in any other state. Is that me again? Sorry, should have put it on do not disturb. I'll have to call her tomorrow. The guide to writing requirements has 42 rules to help you. Now, if you've got good templates, they will implement most of those rules. But there's a really good video on the requirements working group YouTube channel. And Lou Wheatcraft, who's been the co-chair of the requirements working group, been the chair and co-chair for like 20 years. Great presentation on the 42 rules. So I'm not going to go into the 42 rules. but they're there and there's a great video on it. All right, different structures for different types of requirements. You recognize we have different kinds of requirements. I've seen as many as 17 different templates people propose for requirements writing. And I'm thinking about, how am I going to train 17? When we trained to 4, we still had challenges with identifying the right type, but they all have to satisfy this pattern. So we came up with 4 types. Functional performance, if you look in the CBOK, Systems Engineering Guide to the Body of Knowledge, they actually have 2 different types, one called functional, one called performance. The guide to writing requirements doesn't go there anymore. It says, yeah, it's a functional performance requirement, because function without performance is not verifiable, and performance without function is what? The system shall range 20 miles. Okay, so mission-oriented characteristics. These include interface requirements associated with inputs and outputs, right? To ensure that the functions are verifiable. Design requirements. These are constraints on the solution. Make it out of this, don't make it out of that. It's got to be this big, this small, it's got to weigh this, use this much power, and use this standard for the interfaces. Okay, design constraint. So interface requirements are either a functional performance requirement or a design requirement. They're not a separate category. I don't care what the CBOK or anybody else says. This was actually first pointed out to me by software engineers back in 2000. He said, why do we have the same requirement 2 places? He said, you're absolutely right. We shouldn't do that. So got rid of a category called interface requirements. But again, I'm probably a minority here. So, suitability, non-mission specific characteristics addressing fitness for use. Safety, all the ilities, transportation, storage, not directly related to what I wanted to accomplish, but address fitness for use. Reliability, availability, maintenance, safety, as I said, and then environment requirements. These are primarily condition statements that have to connect to whatever it's got to do under a certain set of conditions, or have a certain characteristic after exposure. So weight, power, electromagnetic interference, vibration, acoustic shock. But again, no separate interface requirement type. So 4 types, and I can shoehorn any requirement into one of these 4 patterns. Okay. So now we know what the patterns are. Now I got to figure out the content for the patterns. What content is needed for each element of a requirement? Where does that come from? And how do I know it's correct and complete? So that's the hard part, right? So typically, we have to define the problem and the solution characteristics. Our customers may have an idea of the solution they want, but they may not really understand the problem they have. I would refer you to my YouTube video, How to Be Successful in the Absence of Requirements. Here. Who are the users? But here's some key questions that you always have to be asking. Who are the users and other stakeholders? It's not just about the users, right? There's maintainers too, the developers. What do they care about? So I always ask people, so what problems are you having? What don't you like about the current situation? And then you'll get information from which you can eventually write a requirement. And what's measurable? How would you measure the problem? How would you measure the solution? How are you going to use the solution and deploy it, maintain it, and retire it? What are the critical characteristics? They may have some ideas like it's got to be written in C#. Okay, software's got to be written in C#. Okay, help me understand why, but if that's critical, then it's critical. Are there any other constraints on the solution? So from these answers to these, we have to develop and validate the requirements. Okay, I listened to you. I have synthesized your inputs. Here's the set of requirements I've come up with from your perspective. We call those stakeholder requirements. But you want to check that you haven't misunderstood something. Because when you recast what you thought you heard, that will trigger your client's thinking as well. And they'll go, oh, maybe that's not what I really want. Okay, let's fix that right now before we go off to the next step, right? So I refer you to this video. How do we achieve valid requirements? Well, we start with analysis of the user needs and constraints. I think this is a graphic out of, I don't remember which of my papers. Anyway, but stakeholders, they have needs in terms of desired capability and measures of effectiveness. They may have requirements. It's probably true that if they have requirements, they're not consistent with what they think their needs are, which is why there has to be a reconciliation. Always. Don't simply accept both kinds of input and say, oh, I'm sure they're consistent. Guaranteed problem, right? So some analysis to reconcile the needs versus whatever they think the requirements are. Make sure that they are consistent, CONOPS, measures of effectiveness, stated needs. And then we go down the architecture from the stakeholder level to the system requirements to subsystem requirements. This is recursive. We apply the same process at however many levels of the architecture we need to. And this is what the INCOSE System Engineering Handbook says. But we derive requirements from the analysis. We don't just do Control-C, Control-V down the requirements path and say, oh, I derived a set of requirements at the next level. No, you didn't. You copied and pasted. You may have changed the who, but you didn't actually add any value. You have to go through the architecture and analysis activity and notice that I have derive and validate this way and trace going back the other way. I don't derive from requirements. I derive via architecture and analysis. If you don't do that, you really have no way of knowing that the requirement you thought you generated at the next lower level is any good. It might not even apply at all. So go through the process. We'll do some of this on Saturday. I'm sorry, did you get your picture?
I did.
Okay. If you're coming Saturday, you'll get the whole thing. So questions for stakeholders. What problem are we trying to solve? What are the measurable outputs? If we solve the problem, how would the universe be different? Okay, that's sort of a philosophical way of saying, what would you look for to know we'd actually solve the problem? When I was teaching undergraduates a couple of years ago, I used to say, okay, so what would be a good measure of the homelessness problem? In government, the measure of the homeless problem is how much money they're spending, right? And I said, well, wouldn't a good measure of the homelessness problem be the number of homeless? Kind of makes sense, right? So if you're doing something and the number of homeless continues to go up, what would you say about what you're doing? Not effective, right? So maybe I'll think about something else. But so that was the kind of thing I was trying to communicate. So how would the universe be different? What would we observe and measure to draw conclusions about effectiveness? What are the measurable results? Concept of operations. We will derive lots of requirements from that, not just operations, but maintenance and test. How are you going to use it? Remember, that was the first question I used with the person that needed a new car. How are you going to use it? That's always a good way to start. Okay, you have an idea of the solution you want. How are you going to use it? Describe a day in the life. It's extremely valuable. Start at the beginning. What do you do? What do you want to do? What do you want to accomplish? When you're all done, what are we looking at? External interfaces. With what other entities or persons must the solution interact? You got to find out. You'll find some surprises with this one. So, oh, I didn't know there was another group over there or another system it had to interact with. And are there any constraints, characteristics of a solution that are absolutely critical? In other words, acceptance criteria. All right, I promised a little on completeness. We'll talk about this in more detail. Completeness means that nothing is missing. That's really a subset of correctness. Remember type 1 and type 2 errors, and it applies to individual statements as well as sets of requirements. This is actually how I got into working on requirements a long time ago, because the software people kept saying, well, what do you want a system to do under these conditions? And I had thought about that set of conditions. So I finally tumbled to the idea that I have to have a way of stating a set of requirements that applies to all possible conditions up front. So, and simply tracing to all the parent requirements or needs is insufficient because they may be incomplete. In fact, they probably are, because your stakeholders probably haven't thought about all possible conditions, huh? 5 minutes? Holy smokes, okay. All right, so how do we develop and ensure completeness? This is my 1995 paper. No functional requirement with antecedent is complete unless there also exists one or more functional requirements whose union is the antecedent, not A. Everything I learned, everything I know, I learned in set theory in the 4th grade, okay? The new math, it came in handy. Set of possible antecedents. So we have a condition statement and we have a not condition statement. And the set of requirements, and this is out of our 2004 paper, if and only if all the stakeholders approve of the set of requirements. And we recognize that the requirements have to be approved, in other words, validated by the stakeholders. So architecture and MBSE, I'll refer you to the video. But we're trying to figure out how can I use model-based systems engineering to help us with our requirements. So you start with having a construct. And this is out of the Boeing patent on structured requirements. We had 4 patterns: functional performance requirement, design requirement, environment requirement, suitability requirement, each of which had a different set of the 13 elements. But we put those into our machines. But the mapping, how that gets implemented, it depends on your MBSE tool. So this is an example using Core from Vitec that I used in my graduate class. They have like 40 different classes of possible elements, data elements. So I just told the students, this is what you're going to use. The agent will be either the component or the performer. That's because architecture framework has operational and system views and also has service views and a couple of other things. But I said, this is what we're going to use. I'm the data architect for this project. Okay. So the agent, the shall, mandatory characteristic, function, observable action and output. So function or what's the other thing? Operational activity. And then item or operational item. Interface output is link or need line. Performance attribute, in this case, is a measurable attribute of the function. It's either an attribute of the element or parametric diagram. Condition statement can be a state or an environment or some kind of other input. So it could be an item. The event trigger would be an item and an operational item. Interface input, again, a link or a need line. Timing is an attribute of the function in their data construct. Design constraint, these are harder. This is what the requirements working group was really interested in because it's not functional. But it better be derived from a measure of effectiveness or some other stakeholder concern. Otherwise, you're unnecessarily constraining the solution. So the point is, everything in your requirements is derived from something that's of importance to the stakeholder. Characteristic, required attribute is, has, or does that we use for suitability or environment type. So it could be a function or it could be something from the measures of effectiveness. Environment exposure, duration of input. And I'm sorry, yeah, input and then the duration of that input, which in Core is an attribute of the item or the operational item. You can put a timing on it. So that's what we did for Core. But in general, what you want is to have a simulation. Before you go to build, before you believe your requirements are actually valid, you run a simulation on your requirements. Do they do what they're supposed to do in terms of delivering inputs and outputs and timing and performance, which means you have to have an executable model. So that's where you have to go if you really want to be able to validate your requirements. And notice, if you do that, then you're able to validate your requirements before you actually say they're done. You've built valid requirements as a process. And this is where the real test is in execution of the model. And then if you're really clever, then you can auto-populate your requirements from the validated model. In other words, you don't simulate the requirements, you simulate the model, and then you derive your requirements, auto-generate them. That's what we were working on and didn't finish before I retired from Boeing. So that's still something to look forward to. Some vendor tools are starting to get there. Quality measurement. So this is the last thing. Measurement is a key construct in what we're trying to do here, because we develop requirements, we deliver the requirements, and we want to know if they're any good. So this is a closed loop feedback model in the INCOSE measurement primer that I forced in there. We measure the quality of the requirements and determine action to modify what we're doing so that the requirements come out well. So for example, if I measure the functional performance requirement, and if the function's not observable, it doesn't get a very good score. That was one of our favorites when we were evaluating. So go make the function observable, which probably is going to mean combining some things, and as I explained. So we want to build a requirement from the parts as indicated, and we measure the parts, the quality of each of the parts in the requirement. And that allows us to then be able to say, yes, the requirement is correct and complete when we're all done. But if we don't measure it, we can't be sure. So summary, we want to develop the requirements from concerns, measures of effectiveness, CONOPS, missions, functions, inputs and outputs, and performance. Derivation by analysis enables inherent validation, because I know I have used good material or good input, good process, and the result of building the requirement is I've got a validated requirement because I've used all this good input. And this is lean. It's much better than attempting to inspect quality in at the end. Use the structured requirements as templates, and these help define the data that we need. Validate the resulting requirements by analysis and simulation and stakeholder approval. Ensure completeness by treating the anomalous conditions, the else conditions, and validate the results with the stakeholders, especially the anomaly handling, because they will not have thought about those conditions before. Hey, you know, when we don't have power input, we're going to do this. No, you can't do that. Oh, well, what should we do? You know, new requirement. Use model-based systems engineering to develop the needs, the architecture, requirements, and manage the work. And I went over time, and I'm sorry, but now I'll take questions. So,
Any questions in-house?
hopefully whet your appetite for Saturday.
So I would want, when Boeing, where is a good source for obtaining some educational like resource on this?
Talk to Mike Geringer or John Palmer.
Information about the book. Is it through the library or?
The requirements definition standard, I don't know where it's hosted anymore, but talk to Mike Geringer or John Palmer. Because I have no idea how they've organized stuff anymore. I've been gone 8 years.
Hey, this is Charles Hudson. I am in BCA Core for Equipment Tool Engineering.
Well, as I said, yeah, most of the time we treat validation as something that happens in operational evaluation. We finished, we've delivered, and now somebody's going to take it for a test ride, right? But the idea is fitness for use, and it does what's needed. That concept is embedded in the definition of a technical process, and the system engineering handbook, the ISO standard, say you apply that thinking to everything you produce. In other words, if you produce an analysis, or you produce a requirement, or you produce a schedule, you have to ask, is it going to be able to accomplish what it's needed for? And if you can't answer that affirmatively, then you really don't know what you've got. And you really shouldn't go on until you can answer that affirmatively. That's the idea. Yeah.
So what is your opinion about requirements that have probability in them? Like today I was looking at some requirements that had some probabilities. So it is very hard to verify them because you have to wait for a long time to get that probability. So what is your opinion on probabilistic requirements?
Normally, I would have, I would state in the requirement what it's got to do. And in the verification statement, I would put in the analysis or simulation definition and say what the confidence level has to be. Otherwise, you say, well, it should do this 90% of the time. Well, how exactly, as you say, how will you be able to prove verification? Because if it doesn't do it, oh, well, that was part of the 10%. That's what the supplier will say, right? So that's not in my mind, that's not a good approach. What? So you want to say what it's got to do, and in verification, especially if it's statistical thing like reliability requirement, right? You say what the you can say what the MTBF is under a certain set of conditions. Yeah, or you can use a probability there, but then in the verification requirement, you have to call out how exactly you are going to do that, and that method and success criteria have to agree with whatever you stated. Yeah. So, Josh. Oh, go ahead.
What would you say the most difficult, in your experience, most difficult part of the validation process?
The most difficult part of validation process is doing it, because people don't do it. They just write requirements and throw it over the fence and say, I finished my requirements. So the most difficult part is getting people to recognize that just because somebody writes a shall doesn't make it a valid requirement or even a good requirement.
My experience
Overcoming the bias? Yeah. Yeah. Well, I've been doing this for 30 years and yeah, I've been doing this for 30 years, so don't tell me how to write my requirement. Well, yeah, I'm telling you it's a crappy requirement, and I'm the requirements engineer. You may be the technical expert, but you don't know squat about writing requirements. You've been writing requirements the wrong way for 30 years. You're highly experienced in that. You may be great on HVAC, but you don't know squat about requirements. So why don't you tell me about what you need, and I'll tell you how to write the requirement, okay? I mean, partitioning work, right? So
Online.
Yeah.
Charles Hudson raised your hand. Charles, do you have a question for Dr. Carson?
Yeah, can y'all hear me?
No, I can't hear.
I don't have any way to hear.
Can you try now?
Oh.
Can you?
Mike just said you can't hear the room. It's the mic.
Yeah, maybe.
Can we bring up the chat window? Okay.
Charles, can you type in your question in the chat window? While he's doing that, is there any other questions here? Very briefly. Only really one more question. So go ahead. You said you would like to derive the requirements from the model. And you mentioned that there are 4 different requirement types. I was just wondering, are the models right now assumed to generate all the 4 different requirement types?
Well, that was the purpose of the requirements working group presentation I did on using architecture and MBSE to derive validated requirements, because it's not so obvious for a non-functional requirement. So on Saturday, we can go through some of those patterns, like design requirements. Where does the data come from in a model to substantiate and validate a design requirement or an environment requirement? I went through in using core and the way we had defined the data model, where to find everything you needed. But it's going to be highly dependent on the tool you're using. And of course, it's going to be highly dependent on the requirement pattern you're going to use. So I emphasize, you start with the requirement pattern you want to have in your organization, and then you adapt the tool to satisfy your process. The wrong way to do it is go buy a tool and now figure out what your process is. That's not the right way to go. So define the process you have, what patterns you want to use in your organization, how many different types of requirements you want. And there's some options in the guide to writing requirements. And then adapt whatever tool, make sure it can deliver those patterns. And it can be a little bit difficult, especially for the non-functional ones, but you can find a home, you can find a way to do it. And I showed one way to do it. Yeah, good question.
So I think that's about all the time we have. John, we have one question. Okay, you can finish it.
Which it must and shall, and this has been
Yeah.
coming up recently with the Supreme Court.
Yeah.
About
Must and about shall. Shall doesn't mean mandatory. Yeah.
what's your sense of the industry in terms of adoption of a different imperative for the mandatory characteristics, shall versus must? What do you think the industry is in terms of a transition, or is it transition?
Well, yeah, that's a good question. He's asking about transition from shall to must or anything else in industry. So I was shocked that the guide to writing requirements actually says don't use must. Because I was getting badgered when I was at Boeing 10 years ago about, hey, you know, we have to transition to must, because the FAA or somebody else, the FDA, I don't know, somebody was saying you got to use must because the Supreme Court says, huh?
It's not the old-fashioned word shall.
Yeah. So, and frankly, now we're into a religious war, right? Some people say we got to do must. Some people say don't use must, got to use shall. And my point is, pick whatever word you want, put it up in the front of your spec and say, any statement that includes this word is a mandatory provision and is a basis for acceptability. Then you're covered. I don't care what the Supreme Court says, because your contract says, if it says shall, then it's mandatory, and it doesn't matter what the Supreme Court says, because your contract has that clause in it. That's my approach. And then people can go have their philosophical discussions about must versus shall, and I don't have to participate in that.
That's a good way to end.
Okay. And I am, okay. Thank you. Did you stop the, oh, I have to stop my recording. Oh,
Before we start mingling around, it was a great success tonight.